have a specific method of extraction whereby, since for them they exist as free metals, they are just dug. That's why if you suspect that a given area has gotten gold, you simply go and dig until when you reach that area or that part where gold is. Therefore, these ones exist as free metals. Therefore, for them, they are just dug and they are gotten out of there. Therefore, here we shall not basically look at a specific method of extraction. But these highly reactive metals, these ones that are highly electropositive, that is potassium, sodium, calcium, magnesium, and aluminium, for them they are extracted by what we term as electrolysis. They're extracted by what we term as electrolysis. And from senior 3 work, electrolysis. What is electrolysis? Electrolysis is simply decomposition of a compound. Decomposition of a compound either in aqueous state or in molten state by passing what? By passing electric current. So this is by electrolysis of their fused salts. Okay, and here these ones are going to be extracted by what we term as what? Reduction. Reduction using either coke, which is carbon, or carbon monoxide. So our reduction, we shall either use carbon. Remember, carbon. Coke is a form of carbon which is amorphous carbon, like charcoal. So coke is amorphous carbon. So coke, sometimes they use the word coke, sometimes they use the word carbon. Or we can also use carbon monoxide. When you remember carbon and this compound, that is a senior 2 topic. You looked at carbon and this compound, and you looked at carbon as a reducing agent. You also looked at carbon monoxide as a reducing agent. So we are using coke or we are using carbon monoxide. Then our mercury, our silver, our gold, those exist as free metals. Therefore, they are simply dug. These exist as free metals. And therefore, they are simply dug from areas where they are suspected to be present. So, in our extraction of metals, this is what we must always remember. Our reactivity series, this table here, is going to play a very vital role. A very vital role whereby we must know that since this is very, very electropositive, it is extracted by electrolysis. And we are using fused salts. Remember, these metals here exist in compound form, whereby they are combined with other elements. Therefore, then these ones that are moderately reactive are extracted by reduction using coke or using carbon monoxide. And we shall see even in reduction, we shall have chemical reduction, we shall also have thermal reduction, whereby we simply heat, whereby we shall involve some bit of roasting. So we shall have chemical reduction, we can also have thermal reduction. And then these are the least electropositive metals. They exist freely, not in combined states. Therefore, for them, you simply dig, and once you reach the area where they are found, you get them out. Sometimes the impurities on them may be removed by use of some other chemicals. So these are our methods we use in extraction of metals. But in extraction of metals, what plays a very vital role is going to be the reactivity of a given metal. And the reactivity of a given metal, we shall get it from our reactivity series. Please copy that very fast. So after looking at the reactivity series, and we have used the reactivity series to see which method is going to be applied for each metal, we are going to start away. Which metals are examinable? When you look at potassium, sodium, calcium, and magnesium, they're simply extracted by electrolysis of their fused salts, whereby for sodium we shall basically use sodium chloride. But for aluminium, we also use electrolysis, but we shall not use aluminium chloride. We are going to use, we shall use electrolysis of molten aluminium oxide. So whenever they ask you what are examinable at your level, potassium, sodium, calcium, magnesium, the examinable element metal there is sodium. Then we shall also look at aluminium. Then these other iron, zinc, lead, copper. At your level, we shall talk about iron and copper. We shall leave zinc and lead at a higher level. For A level chemistry, that's why we shall look at extraction of zinc. We shall also look at extraction of what? Lead. But here at O level, we shall basically look at iron and then copper. We shall not look at gold, we shall not look at mercury, we shall not look at silver. Therefore, basically, how many metals shall we see at ordinary level? We shall see sodium, we shall see aluminium because it's also examinable. Then it is on the syllabus. Then we shall also see iron, and then we shall see copper. After we have looked at all that, then we shall call extraction of metals done. Okay, so let us look at sodium, extraction of sodium. And remember, I've just said these ones are extracted by electrolysis. They're extracted by electrolysis. So by electrolysis, here we are going to use a salt of sodium, a fused salt of sodium. Remember, sodium, we have very many sodium salts. We have sodium nitrate, we have sodium carbonate, we have sodium chloride. But what is the most common one and the most available, most accessible, is our common salt, which is table salt. Therefore, we shall extract sodium. Some of you come from the western region. Some of you even have extracted this sodium. You've carried out crystallization of salt, which is table salt, from Lake Katwe. So we are going to look at extraction of sodium, but we shall use electrolysis. Among the salts, we shall use sodium chloride, which is common salt or which is table salt. So we are going to look at extraction of sodium, and the method we are going to use, because it is highly electropositive, we are going to use electrolysis. Electrolysis of fused sodium chloride. Okay, and what must always come into your mind? What must always come into your mind every time we talk of the word electrolysis? Every time we talk of the word electrolysis, there are things that you must always remember. What are those things? That in our electrolysis, we must know what must go to the anode. It means that we must know the anode, what the anode is made up of, The anode is the positive electrode. And then we must also know what the cathode is made up of. And you remember from our senior 3 work, the cathode is the negative electrode. And after knowing what those things are made up of, then we must know what is going to migrate there. And after it has migrated there, what is going to be selected for discharge. And therefore, we shall know what equation will occur at the anode, what will take place at the cathode. Since we are looking at electrolysis, it means that those things must be there. And you must always have reasons why your anode or your cathode is made up of what it is made up of. Even when you look at the batteries, I saw when the physics teacher was teaching, when you're looking at the battery, the common battery, the dry cell. Okay, let me use the dry cell. You have that, I'm using this. If that is my dry cell, okay, you'll have that part, you'll also have that part. So therefore, you'll have the positive terminal, you'll also have the negative terminal. Because when you're going to fix them into maybe a battery holder, a cell holder, you'll see that one must be put at the other side, even another one must be put at the other side. So even in our electrolysis, we must have the positive terminal, or what the positive terminal we are terming as our positive electrode. Then we must have our negative terminal, which we are terming as our negative electrode. So we are looking at electrolysis of fused sodium chloride. Fused, it is in solid state. When we shall pass electricity there, it will change from solid state, and then it will go into molten state. It will melt, and it will be in what we term as the molten state. Remember, we said in electrolysis, for you to conduct electricity in electrolysis, for electric current to pass through, one, you must be either in molten state or you must be in aqueous state. And then you'll allow electricity to pass through. So we are looking at extraction of sodium, and the method we are using is electrolysis of fused sodium chloride, which is our common salt, or which is our table salt. And what is examinable here? One, you must be in position to describe what takes place. Two, you must be in position to draw that setup of apparatus. And you must give reasons why each electrode is made up of that. And you must also give reasons why you're using some of the reagents in that electrolysis. So sodium is extracted by electrolysis of fused sodium chloride, and by a process known as the Downs process. Therefore, that setup, the whole of that setup is what we term as the Downs cell. How does the Downs cell look like? Therefore, during our extraction, we use what we term as the Downs cell. And in our Downs cell, how does it look like? You must be in position to draw it. For us here in chemistry, you're allowed to use a ruler. It's not like in biology whereby you use your free hand, but there are key parts whereby they must not be sharp, but you're allowed to use a ruler so that your work is very neat. So if you know you cannot draw very neat diagrams, then use a ruler. Use a ruler so that your work is very neat. Me, I have not used the ruler because I'm trained to do that. And that's why I'm paid. So I must be neat. So when we look at the Downs process, which Downs process involves the Downs cell, you must be in position, because this is very cheap. This is very cheap to draw. So a question can come in paper 2 whereby you're required to draw, and after you've drawn, you're required to talk, to talk and write whatever is taking place. But it can also come in paper 2 whereby they have drawn for you, whereby you're only required to label. So don't take this and say, it is very complicated. This is very simple. So during extraction of sodium, remember we are using electrolysis of fused sodium chloride, but the process involved is known as the Downs process. And the setup of apparatus where that extraction takes place is what we term as our Downs cell. Remember, we are saying electrolysis. That's why we have the negative terminals, and the negative terminals are made up of iron. Then we have the positive terminals, and the positive terminals are made up of what? The positive terminals are made up, the positive terminal is made up of carbon. They can use carbon, they can use steel, okay? Remember, steel is an alloy, which is also made up of mainly carbon. Okay, so this is our Downs cell. In our Downs cell, what do we put in our Downs cell? One, we have the cathode. The cathode is made up of iron. Okay, we have the anode. The anode is made up of carbon. Okay, but the cathode and the anode are separated by what we term as, it would be like a wire mesh, but this wire mesh is made up of iron, and that is what we are terming as our iron gauze diaphragm. Okay, but on those negative terminals, that is the cathode, we have inverted troughs. Remember, when you're looking at gas preparation, we use the water trough. Okay, so we have our troughs, and the troughs have been inverted over our negative terminals, and our negative terminals are the cathode. Okay, but one of the trough is connected to a tank that is made up of iron, but in that tank you have an inert gas. An inert gas. Which inert gas are we using? We are using nitrogen. We shall see why we are using nitrogen, and we shall see why the anode is made up of carbon, and then we shall see why the cathode is made up of iron. Okay, so we have outlets. And then we have inlets. One outlet is taking out chlorine. Remember, chlorine is going to be given off as a waste gas, okay, which will be used for other purposes. But in the inlet, what do we put there? We put there sodium chloride and then calcium chloride. But remember, all this Downs cell is run. During that extraction, you're using electricity. And if we are not to use calcium chloride, we would use a lot of electricity, and it would not be too economical. Okay, so why do we put calcium chloride with sodium chloride? It's simply because we want to reduce the melting point. We are reducing the melting point of sodium chloride from which temperature? From a temperature of 800 to what? To 600. Remember, in electrolysis, we are using electricity. Therefore, sodium chloride alone, if it was to be melted, okay, to change from solid to molten state, it takes place at a higher temperature. And therefore, it means that you would use a lot of electricity. Therefore, we put there is another compound, and that compound is known as calcium chloride. Therefore, the work of calcium chloride is to lower the melting point of sodium chloride from 800 to 600. Okay, but remember, in electrolysis we are saying that a substance will conduct electricity, but after it has conducted electricity, it must be decomposed. It must be broken down. Therefore, it means that our sodium chloride, okay, in its molten state, it will be decomposed to what? It will be decomposed to sodium ions plus our chloride ions. This is in molten state, not in aqueous state, but in molten state, form of a liquid. Okay, so what happens during electrolysis? Remember, in senior 3, sometimes I forget and I say, remember we looked at this, but sorry for that. In electrolysis, that is in senior 3, you looked at factors. You look at for selective discharge. Okay, the ionic theory, the positively charged ions, where do they go? They go to, the positively will go to the negative electrode. And what is our negative electrode? Our negative electrode is the cathode. Then the negatively charged ions, where do they go to? They go to the positive electrode, and the positive electrode is the anode. Therefore, during electrolysis, what really takes place? At the cathode, we shall have our sodium ions going there. But you must remember that what takes place during electrolysis at the cathode. At the cathode, after you've gone there, you must undergo reduction. What is reduction? Reduction is addition of what? Addition of electrons. Therefore, sodium ion will gain 1 electron, and therefore you'll form sodium metal. What will take place at the anode? At the anode, the negatively charged is the one which goes to the positive electrode, and that is the chloride ion, still in molten state. But remember, what takes place at the anode? What takes place at the anode? There is oxidation. And what is oxidation? Oxidation in terms of electrons it is the removal of electrons. Therefore, here what happens? You will get rid of electrons, and remember, what do you form? You're going to form our chlorine gas. Remember, chlorine, when not in combined state, it exists as a diatomic molecule. Therefore, that is what you form. But remember, you need to balance these equations. How do you balance these equations? By putting here a 2, and automatically you put here 2. This one is the same as this, which is our chloride ions. Okay, giving us our chlorine gas, which is given off as a waste gas, plus what? Plus our 2 electrons. So here, for what is going to take place at the anode and the cathode, we are simply using facts from electrolysis. We are using facts from electrolysis. Therefore, that is the chemistry. But let us look at what really takes place. After you've fused sodium chloride and calcium chloride into a down cell. In the down cell, we have our cathode, which is made up of iron. We have our anode, which is made up of carbon. Okay. On top of the cathodes, we have inverted troughs. Okay, it means that this sodium you're going to collect here in molten state is the one which comes and collects this side. Therefore, after it has collected this in the inverted trough, what happens? It will rise, and therefore it will be collected where? In the tank, where it will be collected. That is our tank. Okay, so what really takes place? What really takes place? Since this is electrolysis, after you've put sodium chloride and calcium chloride into a down cell, you're passing electricity there. What happens? The fused sodium chloride will change into molten state, and therefore in molten state it can ably conduct electricity. Therefore, after it has during that process of passing electric current through it, it will, in the process of conducting electricity, it is also decomposed. It is also decomposed into what? It is decomposed into sodium ions and then chloride ions. Then what happens? The chloride ions being negatively charged, they will go to the positive electrode. Okay, and then the sodium ions being positively charged, they will go to the negative electrode. But you must know what takes place in electrolysis, that once you go to the cathode, okay, you're going to, once you're selected for discharge at the cathode, you're going to undergo reduction, which is addition of electrons. That's why we have added this electron here. Once you go to the anode, what takes place? Once you reach the anode and you've already been selected for discharge, what happens? You're going to undergo oxidation, which is removal of electrons. That's why I first removed one and I formed the chlorine this side. But I told you I cannot have only one chlorine atom. Remember, chlorine, when not in combined state, it exists as a diatomic molecule. That's why I had Cl2 gas, and it is a gas. We have just looked at chlorine and this compound. Therefore, you balance your equation, and that is what you form. Why is the anode? Why is the anode made up of carbon? Why is the anode made up of why is the anode made up of carbon instead of iron? That is the question. If the anode was to be made up of iron, what would take place? Chlorine would react with the anode, with the iron, and you'll form another compound which will be iron 3 chloride. That's why our anode is not made up of iron. Then when you look at the cathode, our cathode, remember our cathode is made up of iron. There is no way sodium will react with iron. So our anode is made up of carbon instead of iron, because they will, if it was to be made up of iron, we have just looked at chlorine acting as an oxidizing agent. It would react with iron to form iron 3 chloride. And the other possible question here is going to be, why do we have these iron gauze diaphragms separating the cathode from the anode? Remember, what are you forming at the cathode? At the cathode, you're forming sodium. And at the anode, what are you forming? In this here, you'll form our gas, our chlorine gas. Therefore, if they were not to be shielded, if you're not to shield this carbon from this cathode, it means that the sodium you form would react with what? Would react with the chlorine gas, and therefore you'll form back your sodium chloride. Yet for us here, we are interested in what? In sodium alone. That's why we shield the anode from the cathode by use of our iron gauze diaphragm. Therefore, the work of the iron gauze diaphragm is to prevent, or is to shield the cathode from the anode, so that the chlorine formed does not react with the sodium that has been formed. Remember, sodium is very reactive since it is highly electropositive. Therefore, our down cell looks like that. Why are we adding calcium chloride? The work of calcium chloride is to lower the melting point. The melting point of sodium chloride from 800 to 600 degrees Celsius. Please, never Isaac, if you cannot quote these temperatures correctly, simply just write, the work of calcium chloride is simply to lower the melting point of fused sodium chloride. But if you're sure of what you're talking about, the Sodium chloride alone will melt at this temperature. But if calcium chloride is added, it melts at this temperature. Sorry. Excuse me. So that is our down cell. That is our down cell. Whatever you're using, you must know why you're doing so. 2, our tank where we are, remember our negative electrodes, which are our cathodes. On top of them, you have inverted troughs. But one of the inverted trough has been connected to another tank where sodium will be collected. Okay, so sodium, our molten sodium, will collect here. Then afterwards, it will rise and then it will be collected in this iron tank. The iron tank is filled. The iron tank is filled with a gas, and that gas is nitrogen. Why is it filled with the gas nitrogen? Because nitrogen is inert, and at ordinary temperatures, it does not react. Therefore, you don't have any possibility of sodium reacting with nitrogen. If this tank was not to be filled with nitrogen, it means that in the tank you would have air. And what would happen? Sodium would react with air. And what gas will it react with? Which gas will it react with? It will react with oxygen. That's why our tank is filled with a gas known as nitrogen. Nitrogen is an inert gas, and therefore the sodium that has been formed will not react with that gas simply because it is inert. It is unreactive at ordinary temperatures. So that is our down cell, and the process followed is the downs process. I want to leave you with your assignment. Your assignment will be describe how sodium metal is extracted from a named salt. And it is saying no diagram. No diagram is required. And our question is 15 marks. So that is your assignment. Please sit down and think of the reasons why each reagent or each and each substance that has been put here, why it was put there. Because whenever a question is to be set on such, those are some of the key concepts they are looking out for. Even in your description, whatever you're going to use, please tell the examiner why you're using so. So that is our downs process. Our downs process involving the downs cell, and it is basically for extraction of sodium, and you're extracting sodium from our common salt, which is sodium chloride. In Lake Katwe, where we extract salt, there are reasons why it is there. 1, you must look at availability of electricity. 2, you must look at the availability of the salt, the ore. And this time around, our ore, what we term as our ore, is going to be our table salt. So that is our downs process, and our downs process is involving the downs cell, and it is basically for extraction of sodium. We are using electrolysis simply because sodium is very, very reactive. It is highly electropositive, and remember we said from our reactivity theory, we look at how these metals are placed in the reactivity theory to choose which method we are going to use for extraction. Thank you so much. Please remember, always remember to pray. Thank God that you're still alive. Thank God that you're still alive. Remember to pray. Read your books. Thank you so much. Thank you so much. May the dear Lord bless you.
Somera Giant Schools omuli kampasi y'Ebombo Kalule n'eye Kabalagala tubona bweraliikirivu bwonna olw'omusingi okutambuzibwa ebyenjigiriza n'ensoma y'abayizi ey'omulembe mu masomero gaffe gano gonna tusomesa arts ne sciences okuviira ddala ku siniya esooka okutuuka ku siniya ey'omukaaga nga tusomesa abaana okuviira ddala ku mutendero gwa kindergarten okutuuka ku kibiina eky'omusanvu. Tulina abasomesa abakugu mu kubangula abaana n'okubateekateeka. Ebibiina abaana mwe basomera eby'omulembe omuli buli kimu ekikwata ku ebyo bye basoma, ebisuula ebyazimbibwa obulungi, ebigazi ate nga biyonjo. Okumanya ebisingawo tukubire ku nnamba z'essimu ez'owama wamu ne
Kombo University, a private chartered university that offers
Baby Junior Jelly owulira omukwano gwa maama n'okufaayo kwa maama. Baby Junior Jelly owulira engalo za maama ansingira bulijjo anyiriza buli kadde. Baby Junior Jelly abatogo beetaaga.
Nzenga jjajja bazzukulu bange okusanyuka n'okufuna emirembe. Ekyama kyange mbasiiga ebizigo bya Baby Junior Jelly biwummuza bigonza olususu lw'aba baby birimu akawowo akalungi bigoba okubutuka okuleetebwa diapers birungi